Hi. If you've ever used a telescope or a microscope or a magnifying glass, then you have some experience of seeing what a magnified image will look like. I'm Chris Murphy, and I'm going to be reviewing how to calculate magnification, and then also what that value means in terms of the type of image that's produced. The content covered in this video is really going to expand upon magnification, what it means. We're also going to learn how to calculate it, and then what its value means in terms of what type of image is formed, such as if it's virtual or real. Now, to calculate magnification, keep in mind that it is a ratio of your image's distance to your object's distance. The equation you would apply would be equal to negative image distance over your object distance, and watch out for the negative sign. This often gets left out in calculations. Not only that, watch out for the sign of the image and the sign of the object that you're using in this equation. Remember that virtual images have a negative value for their image distance. And objects will have a negative value if they are on the opposite side of your lens from your incoming light or the light source. Now, one thing the magnification value will tell you is the image's relative size to the object. And here we care just about the magnitude of the value, not whether it's positive or negative. So if the magnitude of your magnification is greater than 1, that tells you it's magnified or it's larger than the object. If it's less than 1, then the image is going to look minimized or smaller than your object. So to get an idea of what that means, again, our magnification is equal to the negative image distance over the object distance. And let's say that equals 1/2. So that tells you that your image is half the distance to that lens or mirror as your object. Magnification being 1/2 also tells you that its magnitude, or absolute value, is less than 1. That tells you that the image is minimized and smaller than your object. In fact, it's going to be half the size as your object. Looking at another example, let's say our magnification is -3. As a ratio, you can think of this as -3 to 1. So that tells you that your image distance is 3 times that of your object's distance. In terms of its magnification, we can also look at whether its magnitude is less than or greater than 1. So here we have it being greater than 1. The absolute value of -3 is +3. And that tells you that this is going to be a larger image. It's going to look magnified compared to the object. In fact, it will look 3 times larger than your object. So again, to determine if an image is larger or smaller than your object, you just care about the magnitude. If the magnitude is greater than 1, then it's a magnified image. If it's less than 1, it's going to be smaller and minimized. So where the sign comes into play is that it will tell you if you have a real or a virtual image. Virtual images are going to have positive magnification values. And if you combine this with content covered in other videos related to this topic, we can see why. Magnification, again, is equal to negative distance of our image over distance of our object. And remember that a virtual image is a negative value. So we'll end up with negative of a negative or positive. So again, virtual images have positive magnifications. The opposite holds true for real images. Real images will have negative magnification values. So similarly, we have magnification, again, is equal to negative image distance over object distance. And our image distances for real images are going to be positive. Real images are going to have negative magnification values. Now time to apply this content to a question where a student places an object 30 centimeters in front of a lens, an image is formed 60 centimeters behind a lens, and you want to know the magnification, if the image is upright or inverted, and if the image is magnified or minimized. It may help to first draw out a general scenario of what's happening. At this point, you aren't told if this is a diverging or a converging lens. You can establish what is in front and what is in behind by having the light source on the left side. That tells us that our object here is also going to be on the left side and be a positive 30 centimeters. The image is formed 60 centimeters behind the lens. And remember that with lenses, light passes through. Light is really passing through, going to the other side. So all of your real images for lenses are going to form behind the lens. Virtual images would form on the same side as your object. That tells you important information because now you know that your image distance is a positive 60 centimeters. And again, the object is going to be a positive 30 centimeters since it's on the same side as your light source. Now to answer the questions, let's calculate magnification. And again, it's negative image distance over object distance. So plug in the values that we just determined and use a positive 60 centimeters since it's real over a positive 30 centimeters, which gets us negative 2. So the magnification is negative 2. For question B, if it's upright or inverted, remember UV and IR, which again is a mnemonic that means upright and virtual always go together, and inverted and real always go together. Since it's a real image, it must be inverted. And lastly, if the image is magnified or minimized, remember that comes down to the magnitude of your magnification. And the absolute value of negative 2 is a positive 2, which is greater than 1, so that's going to be magnified. It will actually be 2 times the size of your object. So once again, magnification will tell you a few things about an image. It will tell you if it's magnified or minimized. It will tell you if it's upright or inverted. It will also tell you if it's real or virtual. Most importantly, though, when doing the calculations is to make sure that you use the right signs based on the sign convention going with lens and mirror systems.